The Velocity software helps Windows avoid or prevent most of the excess, unnecessary, performance-losing split I/O traffic, and it replaces it with far fewer storage I/O packets, each one carrying a larger payload of data. And this makes the movement of data between the server and the storage much more efficient, and is very similar to avoiding page splits in SQL wherever possible. And it allows the disk storage to store the data using far fewer storage level operations. Velocity will also help create those nice large free space extents quietly and automatically in the background using only otherwise idle compute resource to make it easier for the Windows write driver to write into. So think for a moment of a busy freeway or motorway at rush hour. Imagine that you've got lots of cars sitting bumper to bumper with one person in each car, and none of them are getting anywhere very quickly. Hopefully you can visualize that and see the miserable look on their faces. Now imagine that each car on the motorway is a storage I/O packet, and each person in each car is your data. What Velocity is basically doing is taking all of the people out of the cars and putting them into buses or coaches and removing all of the little cars from the motorway and getting rid of all of that congestion, so that now all the people, or your data, can now flow to their destination in a much more efficient manner. I hope that analogy makes sense. But that's only half of the story. Velocity also introduces a RAM caching technique into the Windows operating system that further reduces the read I/O traffic that the backend storage has to deal with. And the performance benefits provided are in addition to SQL's own buffering and any caching natively provided by the Windows OS. And really, this is how we could get 30% more SQL transactions done in the same amount of time during that Microsoft I/O reliability testing that I mentioned before. Quite simply, SQL could get more work done in the same amount of time because it wasn't having to wait so much on the disk storage layer before being able to get on with its next transaction, and basically because RAM is much faster than the media in your disk storage. Oh, and it absolutely works with both physical and virtualized SQL servers, and also if you're running SQL in the cloud as well. Storage I/O reduction, optimization, and RAM caching represent a significant reduction in workload that has to be processed by the backend storage. And this is not only true of SQL Server storage traffic, but also other workload types too. So in this example on the screen, let's say the first VM is hosting SQL, and the second VM is hosting the application that interfaces with SQL, and the other two VMs are hosting busy file servers, and they're all sharing that same backend storage. Now, you might have a situation where the traffic from the file servers are taxing the performance of SQL just simply by keeping that storage layer busy. So SQL isn't necessarily the cause of the disk storage being slow, but it would likely be affected by the increased disk I/O queue depths and latency caused by the busy workloads on those file servers. So in this type of situation, my recommendation would be to install the Velocity software on all Windows machines sharing that same backend storage. That way, from the point of view of the storage, it's now simply doing the least amount of work, regardless of which virtual machine is generating the most workload at any given time.